Hello everyone, I am Abhi and this is my submission for the Altair Data Science Contest Pragyan 2025 being held at NIT Tiruchirappalli. Today I am going to walk you through an exciting machine learning classification project where we analyze the mental health in tech survey dataset and predict burnout risk among tech professionals. For this, I used Altair's RapidMiner AI Studio. It's a no-code AI platform that simplifies data processing, model training, and evaluation, making machine learning accessible to everyone. This project follows a structured approach from data preparation to model selection using the auto model process and even designing a custom model workflow. So let's get started. I used the mental health intake survey dataset from Kaggle. First, I will open it in Excel. This is a dataset. We can see it has how often the treatment is taken, the age and gender of individuals, how they interfere with work, whether they work in a tech company or not, and other such details related to working professionals. Now let's start by understanding the dataset in RapidMiner. I imported the data and retrieved it from its location using the retrieve operator. Clicking the Run button allows us to see the results of the data. The data appears the same as in Excel. Here we can see there are 177 examples, that is rows, and 27 attributes, that is columns. Let's go to the statistics now. Here we can check for missing values. Thankfully, our data does not contain any missing values, which is a very good thing. We can also see statistics such as the minimum and maximum for numerical attributes, least and most common values for nominal ones, and earliest and latest dates for date-time attributes. We can visualize the data here as well, but the visualizations don't show burnout predictions here itself because our data is not ready to show the predictions for the required problem statement. Here we can see a bar graph, but it contains duplicate values with the same meaning. For example, female and F represent the same thing, but they are shown as different categories. So I saved this process for comparison. Now, let me show the process I used to make it suitable for predictions. First, I removed unnecessary attributes such as timestamp, country, comments, and state using the select attributes operator. These attributes don't contribute meaningfully to the prediction task and may unnecessarily complicate our model, so they are excluded. For predicting burnout, we need to understand the conditions that lead to burnout. This is where the burnout risk score comes into play. This is the formula I framed, which well suits the required problem statement. Other attributes might also contribute, but from my observations, I concluded that they contribute too little amounts like 0.001 like that. So ignored those attributes since it includes multiplication operator in the formula. We need numerical values as data type for every attribute involved in the formula. But since these attributes are nominal, we create duplicates of these attributes and convert them into numerical values. For example, work interface is copied to work interface original attribute as a duplicate to convert the nominal into numerical values. So afterward, we normalize the values of each attribute to a scale of 1 to 5. You can see 5 normalize operators are used for 5 attributes used in formula. And when we check the parameters of the normalize operator, we can clearly see that we used range transformation from 1 to 5. This ensures each attribute is given a normalized non-biased scale. Once this is done, we calculate the burnout risk score and apply the formula, generating a new column using the generate attributes operator. So we normalize this attribute as well to maintain consistency. Next, we generate a new column named burnout label using the generate attributes operator. If the burnout risk score is greater than 3, we classify it as yes, meaning a burnout chance. Otherwise, we classify it as no. This transformation helps to create meaningful predictions later. The next step is mapping. In the dataset, I found duplicated attributes that essentially have the same meaning, like gender I have shown before. So we use the map operator to replace these duplicate values with a single unified value. Clicking on the map operator and going to parameters, we can see that we selected a single attribute gender. The value mappings list shows that values representing female had several old names, so we replaced them with single name female. We did the same for the rest of the attributes as well. This process ensures that the data is cleaner and ready for analysis. Then, the reorder attributes parameter is used to maintain the attributes order. I saved the process. Let's click on the run button to see the transformed data. These are the newly created attributes. Let's see the visualizations of the data. Let's see burnout risk score distribution. To do that, let's plot a histogram to visualize how burnout risk is spread among the population. Next, let's see work interface versus burnout risk. Let's use a box plot. So this highlights that higher work interface leads to higher burnout risk. So we can now find key observations that affect the burnout risks the most with this data using these visualizations. So before the process's design looks clumsy in the design panel. So let's make it look by hiding them back under the sub-processes. This is the way I highlight the so long clumsy process under sub-process. So let's save it. I saved here. Now let's move on to the auto model process, which helps us automate much of the task. Select the burnout label as target. Then next keep the default one because we are focusing on yes, which means burnout chance. Now select the inputs we must be giving. Here don't select the burnout risk score as input. If we have given it, then there will be no value for the prediction. So then in the auto model, we use various algorithms to compare their performance. Let's select the models. I selected these models because we widely use decision tree or random forest in the classification type of model projects. So first overview. You can see the classification errors of the selected models. By comparing the performance of these models, we can determine which one gives the best results for predicting burnout risk. Let's first look at the performance of the Naive-Bayes model. This model provides us with the density of each attribute in the model and the associated weights of each attribute in the weights. In the simulator segment, after adjusting inputs through a simulator, we can observe how the model changes its output. That is, whether the person is at risk of burnout or not. So, let's try experimenting on it. You can observe the changes, right? Now, let's check its performance. The model shows an accuracy of 80.2% with a classification error of 19.8%. Next, lift chart. We see the cumulative coverage of yes predictions. So in the next, the prediction section shows the confidence levels of yes and no. Interestingly, some examples initially predicted as yes have been classified as no when confidence levels change slightly. Next, let's check out the decision tree model. By clicking on yes, we can follow the path leading to burnout. Factors like work interference, co-workers competition, and leave frequency are highly correlated with the burnout risk. The decision tree is clear in showing us that when these factors are high, burnout risk increases. Remaining all show the similar observations shown for the above model. Let's see the performance. The decision tree model shows an accuracy of 90.4% with a classification error of 90.6%, which is a significant improvement compared to the naive-Bayes model. Now let's look at other models like random forest, GBT, and SVM. The random forest model shows an accuracy of 82% with an error of 18%, which is less efficient than decision tree model for this task. However, the GBT model achieves the highest accuracy at 92%, making it the most optimal model. The SVM model also performs well too, with 90% accuracy. Based on the accuracies and runtimes, I have selected the decision tree model. Now, let's save the process of the decision tree model by clicking on Open Process in it and run it to evaluate and see its performance, predictions, and simulator results. This is the performance as we have seen it before. Then this is the model simulator, and these are the predictions. These are all the rest of the details. Apart from using auto model, we can also create our own custom process design. In the custom design, we filter examples that have a non-missing burnout risk score from the transformed data process. This ensures that only complete data is passed into the model for prediction. We then select the relevant attributes for input using select attributes operator. Click on parameters to see the attribute selected. We also set a role for the label attribute, which is binomial yes or no, to allow for ROC evaluation. Click on the parameters to set the attribute as the label. Place the compare ROC operator next. Place the required models inside it. Now let's use cross-validation. It splits the dataset into multiple parts, trains the model on some parts, and tests it on the others, ensuring that no data is left out of the validation process. Inside cross-validation, we have decision tree and apply model operators along with performance operator. After running the process, we see the ROC comparison and performance vector for the models and also the decision tree. As you can see, using auto model simplifies the processes significantly. It automates data preparation, model comparison, and evaluation, saving time and effort. So, with this approach, we not only get reliable predictions for burnout risk, but also gain insights into the factors influencing burnout in the workspace. So, thank you for your time, and I hope this explanation helps you understand how we transformed the data, applied machine learning models, and compared the performance to achieve the best results.